Today, we're going to pull back the curtain on one of the most complex, yet totally invisible, systems that powers our modern world, the supply chain. It's this incredible system built on a kind of hidden logic that dictates how pretty much everything you own actually gets to you. You've done it 1,000 times, right? You find something you want online, you click that Buy Now button, and a few days later, like magic, a box just appears at your door. But what you've really done is kick off this incredibly precise, super calculated chain of events, and it's all governed by a hidden logic we're about to unpack.
So, to get our heads around this, we're going to use a really simple but powerful analogy, the fluid model. Just picture the entire supply chain as one long pipeline. All the products moving through it, that's the fluid. And warehouses, they're just storage tanks along the way.
And this visualizes the core idea perfectly. See, a wide pipe can hold a lot of fluid. That's just like a warehouse with a ton of inventory. But the fluid itself moves pretty slowly. Now look at the narrow pipe. It holds way less fluid, but it forces it to move much, much faster. This is the whole principle behind just-in-time logistics. You lower the inventory to speed up the flow.
This super simple model gives us some immediate, practical rules for how to run a warehouse. The goal is always to keep the product moving. Anything that causes it to start and stop, any weird layout that creates friction, that's a problem you've got to solve. You're basically on a constant hunt for bottlenecks. But of course, it's not quite that simple. Products aren't a perfect fluid. They're more like a slurry of sand and gravel and rocks. They're granular. They start their journey way upstream in these big units, like a pallet. And then they're progressively broken down into cases, then smaller packs, and then finally that one single item that you ordered. And this whole idea of granularity brings us to the central conflict of all logistics. It is a constant, relentless battle between two fundamental and very expensive resources. Space, which is the physical room you have to store things, and time, which is really the labor it takes to move them around.
So, how do managers even approach this battle? Well, they start with data. And the data shows something completely counterintuitive. This scatterplot here maps an item's popularity, how often it's picked, against its physical volume. Now, you'd expect popular items to be big movers, right? But just look at that chart. There is absolutely no correlation. None.
And this graph shows us why. It ranks every single product by its popularity. Over on the far left, you see this tiny fraction of items that account for most of the activity. These are your predictable bestsellers, but then you have all of this. It's called the long tail, and it's tens of thousands of items that are requested very, very rarely.
This leads to probably the most crucial insight for understanding modern logistics. Every single warehouse is actually two warehouses operating under one roof.
The first warehouse is for those fast-moving, popular items. It's small, it's predictable. The challenge here isn't space, it's all about managing the flow of goods and having the labor to keep up. But the second warehouse, that's for the long tail. It is enormous, it's unpredictable, and its main challenge is managing space. The long tail is what really consumes a warehouse.
So if you're running a business that has this deep internal conflict baked right into it, how do you organize everything? How in the world do you manage that tension between optimizing for flow and optimizing for space?
Well, it really comes down to two main storage strategies. The simple way is dedicated storage, where every single shelf spot is reserved for one specific product. And that's it. The more complex, but way more powerful approach is shared storage, where any empty spot can be used for any product.
Now, the problem with that simple, dedicated strategy is that it's shockingly inefficient. Think about it. A location gets filled up, then it slowly empties as people buy the product, but before it gets refilled, it just sits there empty. When you average that out across thousands of locations, it means your warehouse is only about 50% full at any given time.
Shared storage totally changes this game. By assigning a product to multiple smaller locations, you can free up that empty space way faster for other products. For example, just moving from one location to two instantly bumps your space utilization over 60%. Spread it over 5 locations, and you're up to 75%. Yeah, it's more complex to manage, but the space savings are enormous.
Okay, so all these trade-offs between space, time, inventory, flow, it might seem a little dizzying. But what if I told you there's a beautifully simple, universal formula that connects them all? It's called Little's Law. It just says that the average inventory in a system, L, equals the flow rate, lambda, multiplied by the average time an item spends in that system, W.
Let's see just how powerful this is. Let's say you walk into a warehouse and you count 10,000 pallets. You also happen to know that their inventory turns over about 4 times a year.
With just those two numbers, you can use Little's law to figure out the flow rate is 40,000 pallets a year, which breaks down to about 20 pallets an hour. You just estimated the entire workload of the warehouse in seconds. That's amazing.
Little's law reveals this profound, inescapable truth about inventory. Because the flow rate is mostly set by what customers are buying, if you have a lot of inventory, a large L, then the average time each item spends sitting in the warehouse, that's W, it has to be large too. In other words, lots of stuff just means it's going to sit around for a long, long time.
And that brings us to a final thought. This logic, it doesn't just apply to warehouses. Think about your email inbox, your project backlog at work, even your kitchen pantry. What other complex systems in your life are secretly being governed by this exact same elegant, hidden logic of space, time, and flow?